Welcome student to my YouTube channel Bharat Chem Study. Today we are going to study about chapter 1 for plus 1 class basic concept of chemistry. In this video, that is part 1 of this chapter, we are going to study about basic quantity and basic units, some useful factor, precision and accuracy, a rule for significant figures and some numerical related to it. So let's start with the chapter basic concept. The SI system has 7 basic quantities and 7 basic units. They are listed as: first quantity is length, having unit meter; mass, having unit kilogram or kg; temperature, Kelvin; time, having unit second; electric current, having SI unit ampere; luminous intensity, having SI unit candela; amount of substance expressed in moles. All other quantities and units are derived from these basic units and are called derived quantities and derived units. For example, speed. Speed has the formula length upon time, where length is a basic quantity and time is also a basic quantity, and speed is called the derived quantity. And meter and second are SI units, and the unit of speed is meter per second, is called derived unit. Some useful convergence factors, and these are very important for us because in so many quantities we have to change the units. The first is units for length: 1 angstrom, which is equal to 10 to the power 10 meter; 1 nanometer, which is equal to 10 to the power minus 9 meter; 1 picometer is equal to 10 to the power minus 12 meter. For volume, 1 liter is equal to 10 to the power minus 3 meter cube is equal to 1 decimeter cube. So that means 1 liter is equal to 1 decimeter cube. 1 calories is equal to 4.184 joules. For pressure, 1 atmosphere is equal to 760 mmHg, or 1 atmosphere is equal to 760 torr, and 1 torr is equal to 1 millimeter of Hg, and 1 torr is equal to 101325 Pascal or Newton per meter square. 1 bar is equal to 10 to the power 5 Newton per meter square, or 1 bar is equal to 10 to the power 5 Pascal. 1 electron volt is equal to 1.6022 into 10 to the power minus 19 joules. So these are the important convergence or units which we have to using in the numericals, significant figures. Every experiment measurement had some amount of uncertainty associated with it. Everyone would like the result to be precise and accurate. So let's study what the meaning of precise and accuracy is. Precision refers to the closeness of various measurements for the same quantity. That when we are making 2 or 3 calculations, how precise, how close these calculations are this called precision. And accuracy is the agreement of particular value of the true value of the result. That means how much close of our values are coming to the exact or true value. So let's understand this by an example. Precision and accuracy clearly understood from the given data in the table. If the true value for a result is suppose 2 grams, student 1 in first experiment calculated is 1.95. In second experiment he calculated 1.93 grams. The average is 1.940. So the values are precise as they are close to each other, but they are not accurate because that these two values are not equal to or come closer to the true value. So we can say these two values are precise but not accurate. Suppose student B do the calculation in the first experiment as value as 1.94, the second experiment 2.05, the average is 1.99. These two values are not close to each other, therefore we can say these are not precise. Also, any of these two values are not close to the true value, that is 2. That's why these two values are neither precise nor accurate. Suppose students C do the same experiments. The values are coming 2.01 and 1.99, which are very close to the true result, that is 2 grams, and also these two values are very close to each other. So we can say that the value calculated by this student, that is average 2, is precise as well as accurate. The uncertainty in the experiment or calculation values indicated by mentioning the number of significant figures. So कहने का मतलब ये है कि जब कोई साइंटिस्ट किसी एक्सपेरिमेंट को करता है तो वो उस वैल्यू को नोट करने की कोशिश करता है कि जब कोई और पर्सन वो एक्सपेरिमेंट करे तो उसका रिजल्ट भी बिल्कुल वैसा है। इसके लिए उनको वैल्यूज के अंदर कुछ एक्यूरेसी लानी पड़ती है और इसी को हम बोलते हैं सिग्निफिकेंट फिगर, दैट इज वी टेक दोज वैल्यूज व्हिच कैन बी यूज्ड फर्दर। So rules to find significant figure. First point, all non-zero digits are significant. For example, if someone say 285 centimeters, so here all three values are non-zero and we can say all these three values are significant. In 0.25 ml, here only 2 and 5 are non-zero. That's why we can say that this value is having only two significant figures. The second point, 0 proceeding to the first non-zero digits are not significant. That means a 0 which is present in front of a non-zero is not significant. For example, 0.03. Here there are two zero present in front of 3, but there is nothing non-zero is present in front of 3. That's why these two zeros which are present before 3 are not significant. So this value is having only one significant value. Similarly, in 0.0052, again there are three zero present in front of a non-zero digit. So these zero are also not significant. They are indicating only the decimal position. So this value is also having only two significant figures. Third point, 0 between non-zero digits are significant. That means a 0 which is present between two non-zero numbers is also becomes significant. For example, 2.005. Here, two zero are present between 2 and 5. 2 is a non-zero value. That's why these 0 can also be calculated as significant. So 2.005 will have 4 significant values. 0 at the end or right of the decimal place are also significant, providing they are on the right side of the decimal place. Or 0 can be significant only when it is present at the right side of the decimal place. For example, 0.200. Here 1 0 is present in front of 2, but 2 0 are present at the back of. So these two zeros which are present at the back of a non-zero digit 2 are also significant, but the 0 which is present in front of 2 is not significant. So the value 0.200 has only three significant figures. But if otherwise 0 are not significant, for example, 100 has only one significant figure because no decimal is placed there. So these two zeros which are not at the right hand side of decimal place will not be calculated in the significant figure. So 100 has only one significant figure in this case. Fifth point, exact number have a definite number of significant figure. For example, two balls, 20x, these are infinite significant figures as these are exact number and can be represented by writing infinite number of 0 after placing a decimal place. That is 2 can be written as 2.00000 or 20 can be written as 20.0000. So in such case, these numbers where they indicate a quantity and so many zeros can be placed after putting a decimal can have infinite number of significant figures. Such numbers are commonly expressed in terms of scientific notation or exponential. When numbers are written in scientific notation, the number of digits between 1 and 10 gives the number of significant figures. Meaning of scientific notation or exponential means when we write the value multiply by 10 power, that is called the exponential or scientific notation. 4.01 in terms of 2. When such number or scientific notation is coming, we are not going to count 10 in significant, only the value which is present along with 10 power is tell us about the significant. In this value 4.01 in terms of 2, 4.01, all these three are significant because this 0 is present in between two non-zero, that it also becomes significant. Also, it is at the right hand side of a decimal place, that's why it is also become significant. So 4.01 times power 2 has three significant. Similarly, 8.256 into 10 power minus 3, again 10 power minus 3 we are not going to count, it was only to tell us the decimal places. And 8.256 all are non-zero, so it will be having four significant figures. Tips to convert a number into scientific notation. First, in general, when writing scientific notation, decimal must be placed after one non-zero digit. That is the common rule for writing the scientific notation. For example, 6.022 in terms of 23. Here, decimal is placed after a non-zero digit, that is 6. So whenever we are going to write a number into scientific notation, always try to place the decimal after a non-zero digit. Second point, if decimal is not present after a non-zero digit, we have to shift the decimal. If we have to shift the decimal towards left, then the number of digits we have shifted the decimal must be added to the power of 10 in the exponential or scientific notation. For example, if we have to write 5 to 5.000 in scientific notation or exponential, then we have to place the decimal after first 5. So we have to shift the decimal place to the 2-digit left, that is here. So that means this 2 must be added to the power of 10. So 5 to 5.000 in scientific notation can be written as 5.250 into 10 to the power 2, because we have shifted a decimal 2 digit to the left, so we are adding 2 to the power of 10. Similarly, 23.0 into 10 to the power 2 in scientific notation will be written as 2.3, and because power having 2 and we are shifting the decimal 1 place to the left, so we are adding 1 more to the power of 2. So the value of scientific notation can be written as 2.3 into 10 to the power 2 plus 1, that is 2.30 into 10 to the power 3. So this is the way to write the scientific notation. Always try to place the decimal after a non-zero digit. If we have to shift the decimal towards right, then the number of digits we have shifted, the decimal, must be subtracted or minus from the power of 10, whatsoever the power 10 is having. For example, to write 0.0023 in scientific notation, here we have to shift the decimal towards 3 digits, that means decimal should be present after 2. So here we have to shift the decimal 3 digit towards right. So the value 0.0023 in scientific notation will be written as 2.33, and these 3 digits which we have displaced the decimal must be written over the power of 10 by negative sign. So that's why it becomes 2.3 to the power minus 3. Similarly, 0.23 to the power minus 1 in scientific notation will be written as, here again we have to shift the decimal 1 digit right, so the number of digits must be subtracted from the power of 10. So it becomes 2.3 into 10 to the power minus 1. We are subtracting minus 1 because we are shifting the decimal towards right by 1 digit, and the answer becomes 2.3 into 10 to the power minus 2. So this is the way to write a number in a scientific notation. So that's a very important for you, because in future chapters we have to write the scientific notation in this way. Rules for rounding off single figures: if the rightmost digit to be rounded off is more than 5, then we use, to remove it we have to add 1 in the preceding number. If the rightmost digits to be rounded off are 4 or less than 4, then it can be removed without doing any change in the preceding number, that we already have studied in our previous classes. For example, 4.13 is round off to 4.1. Since 3 is less than 4, and so therefore we will not add anything to the 1, so answer will be rounded off as 4.1. But in case of 5, एक बार दोबारा समझते हैं, अगर हम जिस नंबर को रिमूव करने जा रहे हैं अगर वो 5 है, तो प्रीवियस क्लास में हम क्या करते थे, अगर वो नंबर 5 भी है उसे रिमूव करने के लिए हम 1 ऐड करते थे। बट अब साइंटिफिक वर्क के अंदर इस तरह नहीं करते। तो अगर इस साइंटिफिक वर्क के अंदर हम क्या करते हैं, अगर जिस नंबर को हम रिमूव करने जा रहे हैं वो 5 है, तो हम ये देखते हैं कि उससे पहले नंबर क्या पड़ा है, जो नंबर पड़ा है वो इवन है कि ऑड। अगर तो वो इवन है हम 5 को रिमूव करेंगे, कुछ भी ऐड नहीं करेंगे। लेकिन वो नंबर अगर ऑड है तो हम 5 को रिमूव करेंगे और उस ऑड नंबर में 1 ऐड कर देंगे। For example, 4.35. Here we are going to remove 5. So, because the last number is 5, to remove 5, the number which is present before 5 is 3, which is odd. So, we have to add 1 in that. So, the rounding of answer will become 4.4. But in 4.25, here again we are going to remove 5 to round off, but the number present before it is 2, which is even. So, in this case, we are not going to add anything. So 4.25 will be rounded off and be written as 4.2. Next point, in addition and subtraction, the result should be reported to the same number of decimal place as that of the term present with least number of decimal place. मतलब है कि जब हम किसी वैल्यू को ऐड करेंगे या सब्ट्रैक्ट करेंगे, उस केस में हमारे आंसर के अंदर भी उतने ही डेसिमल प्लेस होनी चाहिए जितनी कि हमारे सबसे छोटे नंबर में है। Let's understand this by an example. For example, we have to add 4.1 plus 6.21 plus 7.008. The answer is basically coming 17.318. But to write it in a significant figures, we have to write the answer. The reported answer should contain the same number of decimal place which are present in the least number. Here, the least decimal place is only 1. So our reported answer must also have only 1 decimal place. So the 17.318 will be written as only 17.3. But before removing the another number, the rule for rounding off must be taken into consideration. Here we are going to remove 1 and 8, and this number 1 is less than 4, therefore we are not going to add anything in. In multiplication and division, the result should be reported to the same number of significant figures at present in the least precise, that is the small numbers. Let's understand this by an example. For example, if we are going to multiply 2.2120 into 0.001, the actual answer is coming 0.024332. But we should report, or we should note down the answer according to the rules. So according to the rules for multiplication and division, our answer should contain the same number of significant figure as present in our smallest number, or the least number of significant figure must be present in our answer. So in both of these numbers, the least number of significant figure is 2. Here 2. 0, 0 are not significant, so here is 2 significant figure. In these figures, the significant figure are 2, 1, 2, 3, 4, 5. 5 significant figure are present here and 2 significant figure are present here. So our answer should also contain only the least number of significant figure. That means 2 significant figures. So our answer should be 0.024, and for that we have to remove 3. This 3 is less than 4, therefore nothing should be added, and our answer should be reported as 0.024, which contain only 2 significant figures. Now, numerical based on significant figures. First, express the following in terms of scientific notation. First is 0.0048. So, again here the decimal place is to be shifted after a non-zero, that is 4, and we have to shift decimal 1 to 3 digit towards right. So the answer will be written as 4.8 into 10 to the power minus 3. Because we displace the decimal 3 digit to the right, that's why we are writing power become minus 3. In second point, again the decimal should be placed after one non-zero, that means after 2. So we have to shift the decimal towards 2 digit towards left. So these 2 digits must be written above power of 10. So the answer is coming 2.3400 into 10 to the power 2. Third, here is no decimal place is present, so we have to place decimal after the first 8. So we have to shift, because in most of the numbers the decimal place is placed after a number. So we suppose that decimal is placed after the last 8. So we have to shift the decimal towards 3 digit towards left. So the answer becomes 8.008 into 10 to the power 3. In case of fifth question, the answer is come to 5.000 into 10 to the power 2, because we shift the decimal towards right by 2 decimal place. In the fifth question, again we have to displace the decimal 3 digit towards right. So the answer is coming to be 1.2 into 10 to the power minus 3. Second question is express the following number to 4 significant figure. So in this number, 1 significant, 2 significant, 3 and 4. There are 4 significant, and here we have to round off only up to 4. So we have to remove 8. But this 8 is more than 5, so we have to add 1 in 7. So the answer for this becomes 5.608. In second question, again we have to round off up to 4 significant figures. So 1 significant figure, 2 significant figure, because these are non-zero. Third and fourth. So again we have to remove 2, which is less than 5. So we are going to add nothing, and the important answer will be 32.39. Question number 3. There are 1, 2, 3, 4 significant figure, and we have to remove 8, because 8 is more than 5. So we have to add 1, and then this 9 become 10. So that 1 should be shifted to here, and the reported answer will be 1.790 into 10 to the power 3. In the fourth case, again these 0 are not significant. These 0, because they are present in front of a non-zero digit, therefore these all 3s are not significant. So here the significant value starts from 7, 8, 3, 7. So we have to add all these 4 significant values. So the answer will be written in scientific notation 7.87 into 10 to the power minus 3. Next is to express the answer to the following calculation up to appropriate number of significant figure. So first our question is, we have to multiply 3.24 with 0.08666, and we have to divide it by 5.06. So after doing the calculation, the answer is coming in our calculator as 0.056088374. But according to the rule of significant figure in multiplication and division, the answer should contain the least number of significant figure present in our calculation. So in our calculation, first number containing 3 significant figure, because all 3 are non-zero, and the second value is having, these are not significant, 0 is not significant because they are present in front of a non-zero value. So this value is having only 1, 2, 3, 4 significant figure, and The last value is also having 1, 2, 3, 4. These 0 are in between two non-zeros, so these are also significant. So first value there are 3 significant, in second 4, and in third is also 4. So our answer must contain only least number of significant figure. Our answer must contain only 3 significant. So we have to round off this answer only up to 3 significant. This 0 is present in front of non-zero, that's why it's not significant. This 0 is also not significant. So our significant values start from 5, 6, 0 and 8. And because we have to write answer only up to 3 significant, so we have to remove the 8. And because this 8 is more than 5, so we have to add 1. So our important answer up significant figure will be written as 0.0561. Because we have to round off the answer to write up to 3 significant, so we have to have the rule for rounding off in our mind. Similarly, the second question we have to add 0.5 plus 3 to 4.65. And the calculations come to be 325.15. But according to rule of significant in addition and subtraction, so the reported answer should contain the same number of decimal place as present in the smallest number, and that means up to least decimal place. So the least decimal place is only 1. So our answer should contain only 1 decimal place. So the reported answer will be written as 325.2, because this 5 we have to remove, and in case of 5 the preceding number is 1, which is odd, so that's why we are adding 1. So the answer is 325.2. Always remember, by rounding off, the rule for rounding off must be kept in mind. In third case, 943 into 0.0034 plus 1. Here first we have to do the multiplication, and then we have to add 101. The calculations say that when we multiply 943 with 0.00345, the answer is 3.25335. Again, after doing the multiplication, we must follow the rule for multiplication. The rule for multiplication or division says the answer should contain the same number of significant as present in the least number. So the least number significant is 3. So our answer should also contain only 3 significant. That's why we are going to change 3.2533 into 3 significant, which is come to be 3.25 plus 101. Now while adding, using the rule of addition, answer is come to be 104.25. But according to the rule for addition, the answer should contain the same number of decimal place as present in the least number. So here decimal place is 2, but here decimal place is 0. So our answer should also contain no decimal place, so we have to remove 25. The answer is reported as 104. Simplify the following. This you have to try yourself. I am providing the hint for you. And the answer is also I am providing. The answer is coming 2.795 7. But reported answer should be written according to the rules. So reported answer come to be this. So these are the answers and reported answer I am providing. Reported answer means the final answer we should write, which is acceptable according to scientific. So try yourself. Do more practice from the book. Similarly, find the significance of each of the following. So in scientific notation, we are going to count the significance of only the front number, not the 10 power. So here 1, 2, 3 all are non-zero, so all are significant. So in the first answer there are 4 significant. In second answer, all the 0 in front of a non-zero are not significant, so it contains only 3 significant. Third also it contains 3. In fourth, these two 0 which are present in front of a non-zero are not significant, but the 0 present at the right of the decimal place are significant. Therefore, it is also having 3 significant figures. This 3 and these two 0 are also become significant. But sometimes when we are writing the values are too high or too small. In such case, we have to use some prefix. These prefixes are sum multiples and multiple. Sum multiples are used to present 2 small values, and multiple are used to represent 2 high values. For example, to deci, we are writing 10 to the power minus 1. For example, centimeter, we are writing 10 to the power minus 2. For milli means 10 to the power minus 3. For 10 to the power minus 6, we use micro. Nano means 10 to the power minus 9. For example, 1 nanometer means 10 to the power minus 9 meter. Pico, 10 to the power minus 12. Fermi means 10 to the power minus 15. Atom means 10 to the power minus 18. Similarly, to represent high value, deca means 10 to the power 1. Hecto means 10 to the power 2. Kilo means 10 to the power 3. So when we write 1 kilogram, Kilograms, here kilo represent 10 to the power 3 grams. So 1 kilogram means 10 to the power 3 grams, means 1000 grams. Mega, 10 to the power 6, all aware of megabyte. So megabyte means 10 to the power 6 bytes. Giga means 10 to the power 9. So when we write gigabyte, that means 10 to the power 9 bytes. Tera, that we also aware of, is equal to 10 to the power 12. 1 terabyte means it contains 10 to the power 12 bytes. Penta, 10 to the power 15. Hexa, 10 to the power 18. For example, 4 centimeter means centimeter 10 to the power minus 2. 4 centimeter means that 4 into 10 to the power minus 2 meter, that is 0.004 meter. Similarly, 3 kg means 3 into 10 to the power 3 grams, that means 3000 grams. So sometimes the values, when the value is too big, instead of writing all the zeros, we are adding these some multiples and multiples that we have to learn, because most of the MCQs, these type of questions are coming from this. So study the topic of 7 basic units, rule for writing serial figure, rounding off a number, and practice the numericals. In next video we will study method to express concentration of solution and numerical based upon them. Please like and subscribe the channel for the latest update. Thank you.